Welcome to DevOps Hub. This is Sampath Shivkumar Bodeti. Hope you all are doing great. So what we are going to discuss today? So we are going to look at how to set up a highly available Kubernetes cluster using kubeadm. So just make sure this is not about creating a Kubernetes cluster using kubeadm, right? Like our previous video, this is about setting up a highly available Kubernetes cluster using kubeadm. So let's get started. So before we start, so whatever instance you are coming up, make sure they are Linux host and they are each are having 2 GB of RAM, 2 CPU core or even more. And make sure the swap is turned off and whatever instructions which I am placing in front of you are taken from Kubernetes documentation. So till now, if you remember from our previous video, the kind of cluster we came with is Kubernetes 3-node cluster, where one is master and 2 is worker node, right? Where we used to interact with kubeadm, Kubernetes cluster using kubectl, kubectl2, right? So this is the format we have followed till now. So before moving or talking about high availability things, I just want to quickly introduce about some topology thing. Like let's imagine we are going with 2 cases, like 3-node cluster only, 1 master and 2 worker nodes. So in one case, we are maintaining HCD as a part of our control plane node. It's part of our worker node. So this kind of placement is called something called stacked HCD topology, right? And if we are preferring to place our HCD out of the control plane node, that's out of master node, separately, this kind of setup is called as distributed or external HCD topology. So be aware of these things, because while creating highly available Kubernetes cluster, while going through official documentation, there they are going to ask you like which topology you are going to select. So depending upon the kind of topology or the kind of arrangement you're going with, will have some process. The process will be different. The way we going to set up this high available Kubernetes setup cluster will be different. So as of now, in this video, we are going to go with staked HCD. Like we will be maintaining our HCD as a part of our control plane node. It's the master. So before going to next slide, so why we need to go with external HCD? What is the advantage when compared to stacked HCD? Is just imagine if your worker node goes down, ultimately the HCD server which is inside it, which is placed inside it, will also go down. So this is not something desirable. So in order to make HCD highly available and make it independent with the availability of master node, so external HCD topology came into picture. But here things are going to be a lot complex, as we need to create one more server for HCD, and for its highly available, some more nodes, some more instance you have to spin up. So it's like a lot of servers you are working with. We will see, try to cover this external HCD also in some other video, but as of now, today we are going to see or go with stacked HCD, where we are going to create multiple masters, okay, for high available point of view. So coming back to the picture, so this is the general 3-node cluster we have dealt with till now. If you have not seen our previous videos, we have already made a video on how to set up a Kubernetes ready Kubernetes cluster, using how to set up a production ready Kubernetes cluster using kubeadm tool, where we have in detail discuss each and every step using official documentation of Kubernetes. So it's not simply copy paste of a set of commands. So it's very good video. If you have not watched it, I recommend you to please go ahead and watch that video before you are going with this. Okay, I will make sure to put that link in the description of this video. Yes, so this is a 3-node Kubernetes cluster where we are having one master node and two worker nodes. We can interact with our Kubernetes cluster using kubeadm to kubectl tool, right? So what will happen if our master node all of a sudden gets down? So we will lose control to our Kubernetes cluster, right? Of course, whatever workloads are running on worker node 1 and worker node 2 will still be accessible to the public. But what if you want to query, or what if you want to create some additional resources? Is it possible without a master node? It's not possible, and which is not desirable also. That's the reason today we are making a video on high availability of Kubernetes cluster, where we are going with not single master node. We are trying to set up 5-node Kubernetes cluster where 3 are master nodes. Master nodes, master 1, master 2, master 3. And we are going with 2 worker nodes where our actual Kubernetes workload is going to be deployed, right? So in this perspective, we can interact with our Kubernetes cluster using our kubectl tool with master 1, master 2, master 3 simultaneously. So even if one of the master goes down, even though our cluster is up and running and fully functionable, now even in this case, so we are having 2 masters to interact with our cluster, right? So this is the concept of high availability. So to make things simpler, we are not going to work with all 3 master nodes all at once. Instead of that, we are going to create one load balancer and put the master nodes behind the load balancer and work as and work on the worker nodes. Like you can interact with master node 1, master node 2, master node 3 simultaneously. It will do some load balancing so that the master node, whatever decision it is going to take, it's going to like scheduling, deleting, querying, all these things will happen through a load balancer, right? And ultimately the workload is going to be scheduled on our worker nodes. It can be worker node 1 or 2 based on the decision taken by the master node, control plane node, right? So what is this load balancer? What we can use in place of this load balancer? It depends upon the kind of setup you are going to, or where you are going to spin up all this instance. For example, if you are going with on-prem or bare metal, there are some couple of solutions, like you can go with HA proxy, Cube VPI, Metal LB, Nginx, F5. You can choose any one of these to play a role of load balancing for your master nodes. Or if you are someone who is spinning this setup at a cloud like AWS, GCP, Azure, Alibaba, any cloud, then you can go with load balancer provided by the cloud provider like AWS Cloud Load Balancer. It can be ALB, generally we call Elastic Load Balancer. It can be Application Load Balancer or Networking Load Balancer, Gateway Load Balancer. Like I'm saying a couple of things what we are having. We can go with Azure Load Balancer or GCP Load Balancer. Any cloud provider load balancer will fit fine for this use case. And as I am going with AWS, I'm having my account in AWS and I'm trying to spin this 5-node Kubernetes cluster on my AWS account. So I'm going with AWS Load Balancer, to be specific, network level load balancer, right? So this is the setup we are going to follow to achieve high availability of Kubernetes cluster, right? So let's get started. So as we know, so this is my AWS instance account. You can see as of now everything is empty. We are going to set up each and everything from scratch. And as we are going to set up multi-node, like it's like 3 master nodes and 2 worker nodes, so altogether it's like 5-node Kubernetes cluster. We are going to need 5 instances. Let's launch them. I'm going with Ubuntu OS. So as per our requirement, we should have 2 vCPUs and 2 GB RAM. So T3 Small will be sufficient for our use case. As you can see, it is providing us 2 vCPUs and 2 GB RAM memory. I'm going with existing key pair and everything seems fine. I'm launching the instance. So meanwhile, so meanwhile, I will make some arrangements to SSH to these 5 instances. I need a terminal, so I'm using Mobastem, and I am at this path. I am maintaining my AWS keys. So let me open the 5 terminals quickly. Right, I'm done. So I'm having now 5 tabs where I can SSH to each my instance. Like for 3 master nodes, 3 tabs are there, and 2 worker nodes, and maintaining 2 more tabs. The instance will be up and running by this time, like you can see. So let's quickly label them. Master 1, master 2, master 3, worker 1, worker 2. So as per official documentation, they are referring as control plane node. Just for some easiness, I'm going like master 1. You just understand, even it is control plane or master 1, it's both are the same, right? So now let me quickly SSH to each of the instance. Like I already told you, I'm maintaining my keys at this particular location. So we have SSH to our all 3 master nodes, master node 1, 2, 3. Let's quickly SSH to our worker nodes also. Worker node 1, so done. So last 2 tabs are worker nodes and first 3 tabs are master node, right? So there is a feature called multi-execute on Mobastem, using which we can execute same command on all 5 our nodes, 5 of our instance at a time. Like see, I'm clearing the screen. I am giving a command sudo su hyphen, like I'm changing to root user in all 5 instances all at once. So one more thing we have to do is, as I have spin this 5 instance all at once, all these 5 instances are sharing the same security group. So what I will do is quickly edit the inbound rules. While installing Kubernetes cluster, you also know that using kubeadm, kubeadm is going to spin up the control plane nodes at a specific port. For that, those ports should be open, right, for intercommunication and all. Like for example, if for kube API server it is running at 6443, so it is our responsibility to open those ports. Otherwise, the setup process not be uh, will not be done. So what I will do is, instead of opening each port for each component, as of now, what I will do is for all TCP, like from port 0 to 65,535, I'm going to open all ports for everywhere. Like source, I'm giving like open. This is not a good practice, but my major concern or my major focus is to make you people aware how to set up a high available Kubernetes cluster using kubeadm. So I'm not focusing much on security practice, as the video is going to be like at least 40 minutes. So I'm just focusing upon the setup kind of thing, how to set up high available things and how to place the 3 master nodes behind a load balancer, right? So that is my key focus. So on security and all these things, I'm not going to spend much time. So I'm simply opening all ports to everywhere for simplicity. And now you can see that all our instances are up and running. So one more thing we have to do is we have to create a load balancer. So come to load balancer, create a load balancer. Here we are asked to go with the application load balancer, network load balancer, gateway load balancer. As a network load balancer is going to work with TCP, UDP, TLS, and in Kubernetes we mostly go with the TCP ports traffic. So I'm just going with network load balancer. It is good fit for us. Here I will give a name, quickly give a name like Kubernetes master NLB. Then we have to select one schema, like a scheme, like whether the load balancer we are creating should face the internet or it should not, it should be private, right? For security purpose, you should go with private only. But like I have told you, mostly my focus is on setting up high available cluster using 3 master nodes and 2 worker nodes using kubeadm, and putting those 3 master nodes behind a load balancer. So for simplicity, I'm going with the internet facing only. Just select the, because if I have to go with private and also the subnets also I have not created, I'm going with default VPC, right? So that's the reason I'm going with the internet facing only. Because even if I don't create a private subnets and I'm going to place this, create a private network load balancer also, it's going to face placed on public subnet where it's going to face the internet. A couple of things to be discussed, and like told, not being more specific on security, this is all about setting up things. So I have selected the 3 availability zones, and security group going with default, or you can create one new security group also. So I'm going with the default security group, and the port here I'm giving is 64443, and I have to create one target group. This target group will be having my masters, 3 masters as its target. So basically we can target, create a target group based on instance, IP address, lambda, and ALB masters. I will give a name to target group as masters. Just make sure that port, it is pointing to TCP. It should not be HTTP or HTTPS. It's TCP. Go with 6443 port. This is where our API server will be listening, right? So actually, it's not like we are load balancing the master nodes. We are load balancing the API server, right? So IPv4 is done. It's good. We can go with that. Health checks. Check. Go with TCP. Advanced health checks. What I'm doing is just for making things easier, instead of going with a number of consecutive health checks to mark my node as healthy, instead of going with 5, I'm just going with 2. Then the interval, like the interval also I'm reducing so that it will quickly do health checks on my instance and quickly mark it as healthy. I don't need to wait more time. You can go with default settings also, but I'm just going with these things. Like for every 10 seconds, it will check my health, or even if required, I can go with 5 as well. 5 seconds. Yeah, it's not must, it's not mandatory, but just to cross check TCP health checks. It's good. Next. So now what are instance available? It is showing us. It is asking to pick our target group. So as it is a group of masters, we want to master 1, master 2, master 3. We want to do load balancing on master, right? So we don't need to go with worker nodes. The port it has already taken 6443. Okay, everything seems fine. Great. Now we can create this target group. So it will perform the health checks. Right now health checks are unused. It is like initializing. Now what we can do is refresh, and whatever we have created the group, we can attach that to our NLB. Great. It's just giving a summary. Security group. We will add one. See, I have added the security group. Like, in order to make things simpler, what I have done is I have opened all traffic, like all TCP, fine, at everywhere. So by default, it will not be there in your security group, because what instance can be reaching to your NLB, that is very important, right? When you are making a request, mostly from kubectl command, you will be doing that, which will be sitting on your Kubernetes control plane node. If required, you can install the kubectl externally also. So that should send the request to the NLB, and from here it will select the master nodes which are healthy, send the request to any one of the master nodes available. So that's the flow. So it's very important to change the security group. If kubectl command is not able to reach this NLB, then we cannot interact with the Kubernetes cluster. So I'm opening all ports everywhere to make things simpler. It is not security brand, good security thing, but just for demonstration purpose, I'm doing this, right? So yes, everything seems fine, right? I'm creating the load balancer right now. So it is provisioning. It will take some time. By this time, what we can do is, let's come to our EC2 instance and quickly install our Kubernetes, set up Kubernetes, like using kubeadm, we have to set up, like we have to disable swap, edit route tables and all. Those things I have very exclusively covered in my previous video, like I have said, keeping the time in mind, as this video is going to be long, at least 30 plus minutes. So what I'm going to do is, instead of going to official documentation, kubeadm install, going with installing kubeadm, selecting up like anyone, like I'm going to set up Kubernetes version 1.31 only, following these things like disabling swap, installing container runtime, following along official documentation and setting up each and every node. It's going to take time. So as we have done in our previous video, I highly recommend you to go and check it out if you have not seen it. So as of now, I have made a documentation of all those commands which need to be executed, on all three commands, irrespective of whether it's a master or it's a control plane node, right? A worker node. So what I will do is, I will just copy this one, and as I'm having already SSH into all my instance. So I'm going to clone it on my instance so that I can run it as a script on each and every node. So git clone. Yes, it has been cloned. You can see, just cd to that particular directory. Doing ls, I can see all node.sh script on all my nodes, like 3 master nodes and 2 worker nodes. So what I will do is, as let me become a root user, sudo su hyphen. Now if you can see, I'm root user. So what I will do is, okay, what I will do is, let me clone it here. You understood what happened. The things we have cloned, that file is part of is in our Ubuntu home directory. Now as we have switched to root, at this point of time we are not able to see the script. If we want, we can go and copy those things, but let's do it here also quickly. Maybe I was too quick there. Yeah, if I do ls, I can see the directory. Maybe I was a bit quick, that's the reason here it's not there. Let me execute here only. Git clone. Yeah, sorry for creating a mess. Now we can see, if I am doing ls, we are able to see that particular directory at every instance, right? We are going inside that and doing ls. Now the script is available on all instances. What happened was, before the command was completely put on the one instance. Maybe I was too quick. In multi-execute, it's like taking some delay. I just gave enter. So the command was incomplete, and in some instance, the operation could not be performed. So that's the reason. Now it's done. You can see I'm doing ls on all nodes. We are able to see all nodes.sh. We are having our script there. So what I will do is, as I'm root, I'm giving sh and all nodes script. I'm giving it, telling it to run this script. Whatever instructions are there within the script, execute on this node. So it's working, right? Just let me show you what things I have mentioned here. First thing is, like I have told you, it's like the same thing, like turn off the swap, right? Enable IP before forwarding. By default, it will not be forwarding things. Then checking them whether we have done it correctly or not. Then it will be like installing container runtime D. I'm using Docker repository to install container D. Once we have installed that one, so what I have done is, we have to configure this system cgroup thing from false to true, right? Then I have done using set command in place. Then we will restart the container D, installing updating things on, then installing some certifications and all, curl, and then installing a Kubernetes package of version 1.31, and at last setting up hold on kubeadm and kubectl. That's it. What we have done in previous video, the same things, just to save our time. I think by this time everything must be done. See, everything is done. Kubelet, kubeadm, kubectl were set on hold. So now what I will do is, I will exit this multi-execute. Just pick one, any one, just to verify whether things were done right or not. What I will do is, I will check etc/config file. So this is the file where we have asked to change the, I think it's at 135 it will be, yes, system D C group. Basically it will be false by default. So now it's true. That means whatever steps we have executed, the script worker has done its task correctly. So let's get back. So now all nodes, 5 nodes in our cluster, like we have set up like basic things. We have disabled the swap, like I have told, install container runtime, like container D on all, enable IPv for routing. So everything is done. Now what we have to do is, as we are saying, we are going with multiple masters, like 1, 2, 3. These 3 are master nodes. So we should do initializing, so that, okay, we are authentic, like your master node. As of now, all these 5 nodes are same, right? As per configuration, though we have given a label like worker node 1, worker node 2, master 1, master 2, master 3, but it will only act as a master when we do initializing using kubeadm, kubehit. So that then only the instance where we are going to give the kubeadm init command, there only all control plane components like API server, etcd, scheduler, control manager, all these things are going to be spin up, right? That will make the node act as master, real master. So let's spin up. So what we have to do is, now let's go to official docs and give HA Kubernetes cluster. So a small change is there. As we are having multiple master, the way we initialize, we has to include some set of new things. So this is the first thing, like creating high availability Kubernetes cluster in Kubernetes using kubeadm. This is the first link we can go with. So it's talking about creating highly available cluster with kubeadm. So as I have already told you, it is like saying with the stacked control plane node, the approach requires less infrastructure. The etcd members and control plane nodes are co-located. If you are willing to go with external etcd cluster, this approach requires more infrastructure, and control plane node and etcd members are to be separated. The same thing which we have discussed earlier. So I'm going with this. So before you begin, again it is asking to select with which one you are going with. I'm going with stacked etcd, so I'm selecting this one. And it is asking to go with Kubernetes minimum requirement, which we have already discussed in the starting of our presentation, right? So we can go ahead, and it's talking about creating of load balancer, right, for a Kube API server, which we have already done it. So now what I will do is, for stacked control plane and etcd node, I'm going to setup, quickly setup. How I am going to initialize this, using by this command. Let me take a notepad, copy this one. So this is the command. It is talking like sudo kubeadm init control plane endpoint. The only thing is, we are not going to give the control plane IP, master node IP. Previously we are going with one master. We used to go like that, like we used to advertise that control plane, and we used to carry on from there. But here the thing is, the concept is, your client kubectl command should forward its traffic, like request, to the NLB load balancer, and the load balancer is going to give one master node which is available and which is healthy, is going to give you one master node with which you are able to set up your request. Like you can create Kubernetes resource, or you can query. So this is how the things are going to work. So that's the reason, instead of giving control plane IP address, your master node IP address directly, so we are going to give load balancer DNS and load balancer port with which it is listening actively. So quickly more to load balancer thing. Now, if I'm not wrong, the load balancer should be active by this time. See, the state has changed from provisioning to active. Click it, scroll down, you can see the DNS name, come here, copy it. The port you have to give is 6443. At this port, it is listening actively for your request. So along with this, let's also define CIDR range for our ports. You can get this option from here, port network CIDR. Let us copy that one. The range is, I'm going to go with 10.244.0.0/60. So this will be fine. So make sure to copy entire command, and where you have to execute this command, any one of the worker node. No, sorry, not on worker node, any one of the master node. Like first 3 tabs are dedicated to my master nodes. Master node 1, master node 2, master node 3. I'm going to execute this on this particular master node, right? So it's going to take some time, have some patience. So I think the important thing I have already told you, like our security group, it should be allowed. I have opened my security group, all ports, just to cross check I am doing. Inbound rules, yes, it is accepting all ports, opening all ports and accepting requests from everywhere. Similarly, let me check the security group of my NLB also. I'm going with default. That should be actively listening. Yes, all TCP everywhere. Just cross check. If these things are not done, things will not go smoothly. And you can go to target groups and check the health. So as we are executing the things on one master node, so here these things are unhealthy because these ports are not open, because kubeadm did not spin up a kube API server on these 2 master nodes. As we have selected one master node, here it has spin up the Kubernetes components, and there 6443 is open for kube API server, which is open. That's the reason it's able to probe that one for health check, and it is showing this is healthy. And yes, kubeadm has done its work properly, like pre-flight checks, certification, kubeconfig, etcd, control plane components like kube API, kube controller manager, kube scheduler, everything it has spin up, like created from scratch. We don't need to create these things from scratch. So it has bootstrapped the token and all, everything it has taken care. Now what we have to do is, if you want to execute the commands with normal user, kubectl command, just exit as a root, copy these things. You know what these instructions are going to do. It's going to copy the kubeconfig file to your home directory, right? So now what is the difference we have seen is, previously we used to get only one single token for when we are going to create one master and multiple worker nodes. So not high available cluster. There we, after spinning up, like initializing the control plane, we used to get one token, which we need to copy on worker nodes to add those worker nodes to our cluster, Kubernetes cluster. So if you can see here, it is giving us 2 tokens. One is these tokens are explicitly we need to paste at master servers. Like this is master 2, you have to paste it here. This is master 3, you have to paste it here. And remaining two are worker nodes. For worker nodes to join them into Kubernetes cluster, you have to copy this code. So I'm doing it. So it's done. Now these both worker nodes are joined to our Kubernetes cluster. This is taking some time. It should take some time, no issue for master node, because in these master nodes also it has to spin up Kubernetes control plane components, right? So it will. So here it is done. So here also just exit as a root user, copy this command so that kubeconfig details will be part of your home directory, so that you can execute kubectl command from here as a normal user. So same thing, exit as a root, copy these things. So everything is done fine, right? Everything is done. I just clear my screen. Now what we have to do is, you can check if you want, you can check kubectl get nodes. So three component control plane components are there, like that is three worker nodes, three master nodes are there, and two worker nodes are there as a part of cluster. So we are all together having 5 nodes cluster. So this is a high availability Kubernetes cluster because we are having 3 control plane nodes. So one thing we have to do is CNI plugin, right? We have to install a CNI plugin, and I am going to go with ViewNet. I'm quickly going to copy this one. Make sure to change the version to the version you have just installed. I have went with version 3.1. How can I say? By seeing this version here. Just replace that version in this command and execute it on any one of the master node. You don't need to apply this on each and every master node, because the CNI plugin, the ViewNet pods are deployed on Kubernetes cluster using daemon set. So if you are applying it here, so this will be like, I can show you, like each node will have one daemon, like one ViewNet pod. So you don't need to again apply on these both master nodes also. Now you can see kubectl get pods -a. Like I have told you, it is a part that CNI plugin is deployed like using daemon set way. It's not general deployment. So each node will have one agent, like ViewNet agent. 1, 2, 3, 4, 5. We are able to see 5 ViewNet pods because our cluster is having 5 nodes. If our cluster is like 3 node setup, we are going to see 3 ViewNet pods, right? So everything is up and running. Everything seems fine. kubectl get nodes. See, all worker nodes, all control plane nodes are ready. So we have successfully completed setup highly available Kubernetes cluster using kubeadm, where our 3 master nodes are behind the load balancer. So let me show you how the load balancing is working in our case. Before going that, this is master 1. It is able to interact with our cluster. kubectl get pods -a. Let's try with second master. It is master 2. Let's execute some kubectl command, kubectl get ns. Yes, it is able to interact with our cluster. Let's try to create a nginx pod. kubectl run nginx image nginx from our work, our master node 3. It's done. kubectl get pods. It's in creating state. Just give it some seconds, couple of seconds. It's running. So where, on which node it is running? kubectl get nodes get pods -o byte. So this pod nginx is running on node IP with 31-2-39. If you can see, so that is our 39. That is our worker node 1. So it's running on our worker node 1. If I'm not wrong. Yes. Okay. So here you can see, like, we are able to interact with our Kubernetes cluster using multiple control plane nodes, like master nodes 1, 2, 3. So it's highly available. No matter any what control plane node goes off, like even due to some disruption, we are not able to access one control plane, or one control plane goes down, then also we can interact with our cluster seamlessly. Let me show you. What I will do is, intentionally, I will turn off the master 1. I will stop this instance. So the moment I am going to stop this instance, what will happen is, we are left with 2 masters, that is master 2, master 3, and worker 1, worker 2. So we should not see any difficulty in interacting with our cluster. Like as we have turned on this instance, it went down. So let's execute some kubectl command. It's working fine. If you can see, we are still able to manage our workloads, our Kubernetes cluster. If required, we can create, or if required, we can delete. See, we have successfully deleted this pod. So this is the advantage of high availability. So what we will do is, now we will stop one more master instance, and if you can see, now our cluster is like 1 master, 2 worker nodes. Like master 3 is available, worker 1, worker 2 is available. Let's check, let's try to check whether with 1 master available, can we interact or maintain our Kubernetes cluster. So like this got closed as we have stopped this instance. So master node 3 is available. You can give kubectl get nodes. It is not responding. So can you guess what is the problem? What is the issue? Do you think like whatever configuration we have done, there is something error? That's the reason why we are not able to interact with our Kubernetes setup with this master 3? No. Everything we have set up is as per official documentation and authentic. This is the right way to set up. The problem we are facing is not because of some misconfiguration. Okay, it is because you can see the error. I will make it large. The error is that it is saying from server HCD server request timeout. So the error, so when you are giving the request, kubectl is giving a request, forwarding the request to load balancer, and load balancer finds that out of 3 master nodes, only 1 is healthy, and it is forwarding that request to that particular master node, where it is going to port 6443, where Kube API server is there, which is front end to Kubernetes cluster. The request went there. It has done authentication, authorization, whether the request you have made is valid and not. It has checked every parameter. and after checking everything, it has accepted your request and forwarded your request to HCD for querying. Like what you have requested, kubectl get nodes. How many nodes are part of the Kubernetes cluster? You want to know. So that query, Kube API server has forwarded to HCD, because HCD is the single source of truth. Entire, no matter at any point of time, entire Kubernetes, state is stored in HCD. So it is the problem from HCD. HCD is not able to serve your request. That is the reason for this error. So now what we will do is, I will quickly start this instance, like any one of the instance master node, right? So that to show you with two masters it's working fine. Why only two masters it's working fine? Why with three masters it's working fine? Why with one master it's not working fine? So it's up and running. So we don't need to SSH into that one, right? One master is sufficient. If another master is up and running, it's sufficient. We can give our request from anywhere. This is ultimately we are using kubectl command. This is forwarding our request to NLB. There, NLB, it will check the health of the targets. It will check that, okay, whenever you are making a request from kubectl to NLB, it is only going to forward your request to the healthier instance. So as of now, let's give some time. Even though I am running two master nodes as of now, health checks has to be done. Okay, then only it will mark the instance. Like for health checks, it needs to go with some certain number of things. For marking a node healthy, 2 consecutive health checks to be passed. For unhealthy, 2 consecutive health checks to be failed. So sometime we need to give it. See, now our target system, like it has found two master nodes, master node 2 and master node 3 to be healthy. So now what will happen? From any kubectl command, it may be on master node 2 or master node 3. If required, we can install kubectl command external to our Kubernetes control plane as well. So, but I'm not doing that as of now. So using any kubectl command, when you give a request, it's not directly going to go with that particular control plane node. It's going to go and query the NLB, and NLB will check the health of the healthier instance. So as of now, there are two healthier instance, master 2 and master 3. It will randomly like forward our request to with one master, that is can be master 2 or master 3. Now you can see the same kubectl command will work fine as of now. So let me start master node 1 also. Let's be up and running. So just to tell you again, previously with one control master node, we were not able to access the cluster because HCD was not able to serve our request. Then you will ask, like, Sampath, what is the use case? You are saying highly available cluster, and with one master node you are not able to interact with the cluster or maintain the cluster. Then what is the use? It's fine, because in previously what we have set up, like 3-node Kubernetes cluster where one master is to be there and it is used to serve our request, right? You can have these doubts. So why it didn't went with work with one master node out of 3 master nodes? The reason is, let me tell you the reason. It's not because of misconfiguration or something else. It's because of quorum. Now you will ask me, like, what is quorum? So whenever you're going to with distribution systems, mainly with HCD kind of thing, workloads. So in order for that HCD to serve your request, like read or write, you should always satisfy the quorum. What is quorum? It is the minimum number of nodes which are needed to make your cluster operatable, right? So the basic formula is like total number of nodes. In our case, total number of nodes, like not 5, just we are talking about master nodes, because we are going with stacked HCD. So if we are going with 3 master nodes is going to have 3 HCDs, right? So this quorum is about HCD. So out of 3 master nodes means 3 HCD. So the formula will be like 3 by 2, 1.5 plus 1. That's 2.5. So the quorum should be 2.5. But we can neglect this 0.5 because always we have to go with whole number. So if we are going with 3 master nodes, you are going to have 3 HCD pods, 3 HCD cluster. For these 3 HCD cluster to be up and running, it has to take your request, like writes and reads. So quorum should be satisfied. That means out of 3, 2 should be always up and running. Then only it will fulfill your requirement. So that's what I have given here. For 3 nodes of HCD cluster, the quorum is 2. So I have come up with a small table for your understanding. So the node is highly available, no doubt, but due to the improper functioning of HCD, we did not get our request fulfilled previously. So if we are going with C, I'm talking about nodes means master nodes, and I'm talking about stacked HCD. So the number of master nodes represent that number of HCD. Like if I'm going with, in our case, if we are going with one master node, where 1 HCD will be there. So the formula is 1 by 2 plus 1. That is nothing but 1.5. We have to go with whole number. It's 1. That's the reason. See, when we went with 1 master, 2 worker nodes, 1 HCD server was there. So that HCD server, the quorum is 1 only. As the quorum is 1, it is satisfying our read and write operations. When we went with 2 master nodes, then the quorum for that is 2 by 2 plus 1, that is 2. Even in that case, if we are going with 2 master nodes, then also 2 master nodes should be available for your HCD cluster to work properly. In our case, we went with 3 master nodes. So the quorum for 3 master nodes is 3 by 2, that is 1.5 plus 1, that is 2.5. You have to go with whole number, that is 2. That means out of 3 master nodes, always 2 master nodes should be up and running, which implies that 3 HCD servers will be up and running, which will be capable of taking your request, well, no matter it is write or read operation. So that is the principle, that is the concept why previously the cluster did not respond with the 1 master node running, right? Because the quorum did not satisfy. So tell me, if we are going to set up a 5 node Kubernetes cluster, not 5 node masters Kubernetes cluster along with 1 worker node 2, then what should be the quorum? So in that case, 5 divided by 2 plus 1, that is going to be 3. That means out of 5 master nodes, 3 of the master nodes should be always available, any of the 3, so that HCD will perform its operations seamlessly. So if you are going with 7 master nodes, that means you are working with 7 HCDs, and out of 7 HCDs, 4 should be always up and running in order to your kubectl command to query or give some create some Kubernetes instance to read and write. Okay, so this is the concept. Hope you have enjoyed it. Thank you very much. So don't forget to clean the instance. Like now you can see, like target group, all instances will be healthy. So when you can go with any kubectl command and give kubectl get nodes, get pods, everything will works fine. So we have successfully created a high available Kubernetes cluster using kubeadm, where we have set up 3 master nodes, 2 worker nodes, and we have backed the 3 master nodes using 1 load balancer, that is NLB. That's it. And this NLB can be, load balancing is not mandatory to go with NLB or ELB. We can go with other third-party solutions like HA proxy, Nginx as well. I hope you enjoyed this session. Thank you very much for being patient and giving your time till now. If you have any sort of issues, please reach me on LinkedIn. I will be very happy to assist you. See you. Have a great day.